This is Tech Unmuted, the podcast of modern collaboration, where we tell the stories of how collaboration tools enable businesses to be more efficient and connected. With your hosts, George Shainstein and Santi Cuellar. Welcome to Tech Unmuted.
Welcome to the latest episode of Tech Unmuted. Today, we're going to take a look at the history of AI, really the last 10 years of AI. Santi found a great article, so I'm going to pop it up here on the screen. This was written by Thomas Dorfer, who's a data and applied scientist at Microsoft. And he starts to break down really what's happened since 2012, how we've gotten to where we're at today with AI. And Santi and I will go back and forth a little bit, but we'll break down some of the elements that are in here. So pop it up, make it a little bit bigger on the screen. And Santi, you want to jump in on this?
Oh yeah, man, I love this graph. So, and you know what I love about this graph is that it forces me to have to go back and kind of think about the evolution of things, right? A lot of people actually are probably looking at this graph right now and going, I never heard of these things. And so this is a great opportunity. I'm going to do the best I can. Now, listen, fair warning, I am not an AI engineer, but man, I know enough to be dangerous. And so I'm going to try and be as dangerous as I can today. But at the same time, I want to kind of keep it layman's terms, right? Because we want to be able to make this easy to digest. But, so listen, it's interesting that he starts his article. He specifically said last 10 years, but it's interesting to me that he started with AlexNet. But before I even get into AlexNet, I thought about this. I said, unless we kind of explain first what a neural network is, then AlexNet won't make sense. So let me just take a minute here. So the term neural network, like neural almost sounds like neurology, right? So the term neural network, the best way to describe it is imagine a computer system that is able to literally learn like a human brain. Okay? In other words, it's able to recognize like patterns and things like images and text, but very similar to how the human brain does it. Okay? Hence artificial intelligence, right?
Yep.
Okay. So now that we understand that with that baseline, in 2012, there was a breakthrough that is known as AlexNet. By the way, it was written by a guy named Alex. So he wasn't very creative. Alex wrote it, so AlexNet it is. But what it did is AlexNet, in layman's terms, basically, it made computers better at not just recognizing, but understanding an image. So, George, the last podcast, Sam Husbands, he joined us, and I was with him trying to look at DALL-E and Midjourney. But at the beginning of the podcast, he wanted to ask about how computers actually actually understand and comprehend what's going on. And my response to him was, yes, they do. They can absolutely look at an image, and not only do they recognize, but they understand what it is. And so that is a breakthrough that happened in 2012 with AlexNet. And so that's what that is. That's a great place to start.
And it was the training, right? It was the repetitive nature of, is this what we think it is? Is this a picture of a dog? Is this a picture of a dog? Is this a picture of a dog? Until it starts to say it is.
Yeah.
I saw somebody speak a couple of days ago. The analogy they used, like in those instances, was sort of like an art critic.
Yeah.
Who says, no, it's not a dog. No, it's not a dog. Maybe it's a dog. It's getting closer to a dog. Okay, it's a dog. Right.
Right. So I love that analogy. Everything on this chart, honestly, it's just about improving the learning process when you really get down to it, right? So like every milestone like as I look across this thing, I'm like, yeah, it's just getting better and better and deeper. And so, but yes, you're absolutely right. That was the breakthrough. The breakthrough was, and you know, this is where the term computer vision comes in, where the computer is actually looking, like literally looking at an image, analyzing and understanding. Speaking of computer vision, right? In 2013, right? That's where computer vision switched to a neural network. And so AlexNet was that breakthrough. They went then from computer vision to a whole lot more complexity in the learning process. But basically, computers really started to, again, see and understand. That's the key word, because there's a comprehension. But they started to do it more and more like humans. Again, it's about mimicking the human brain. And so that, and what's the best way to mimic a human brain? Well, you take a computer and you have it analyze and process data from real brains. And so that's how neural networks start to grow, and that's how computer vision starts to switch to that neural network. But in this graph, Thomas has an acronym that I haven't heard in a long time, VAE. And VAE is critical because, again, in the previous podcast, when we were looking at DALL-E and Midjourney, Sam asked a really good question. I go, you know, he's like, is it really learning like the artist's approach to art? And is it, the answer is yes. And this is what it does. It's so VAE stands for, it's variation. So variational autoencoder. I didn't write these things, right? Somebody else came up with these names. But basically what we're saying is it is a creative system. So it's part of the creativity of AI, okay? Where it's able to learn and generate a new version of what's before it, or what data it has received. And so it is creating new versions, not a replica. And that's the key here. The key here is, this is why when we have AI generate an image, it's unique. But in this case, what we're saying is, hey, take this specific type of art and generate the following. And so it's able to understand exactly what you mean by type of art, right? Whatever it is that you chose. Yep. And it will use that to create something new, a complete different variation. And so that happened in 2013. Again, another breakthrough with images. That was a big thing.
And again, a lot of this in this timeline, right up until really a year ago.
Yeah.
These are things that if you weren't directly in the AI space,
yeah, you weren't exposed to it.
You didn't know any of this was even going on. You heard about AI, you heard about, you know, mechanical automation of things and robotic automation, those kind of things. But there was a lot of work that took place that got us to where we're at today.
Yeah, by the way, everybody knows Face ID on your phone.
Yep.
What do you think that's using? It's computer vision. This is why it makes you do all these things with your face and your different angles. And it's computer vision. It is understanding. So when I put on a pair of headsets, or when I take off the headsets, the computer knows that it's me. It doesn't matter, because so yeah, we've been using it, but we didn't really know and understand it until, you're right, until recently, where now it's become like mainstream, right? But listen, here in 2014, he mentioned something called GAN, G-A-N. This is another pivotal moment, because, so by the way, GAN stands for generative. So now we're talking about generating stuff. So generative adversarial networks. Bottom line is, this was a new approach in 2014 that basically allowed a computer to literally generate new content, unique images. So, and it did this from existing data. So that was the key, right? It would take existing data and it would generate something new. But this GAN network, or this approach, this is what became the framework for what today we call generative AI. And so you'll hear that term further down the timeline, the word generative in a little bit, but this is it. This is that pivotal moment where that started to happen. But now we get into 2015. 2015 is all about memory. So now, we got the AIs to look at things differently and to start generating stuff. But we still had to deal with the memory piece of it. Again, we're talking about artificial intelligence. You need memory. And so there's a bunch of terms on here. There's something called residual neural networks. So now we're still talking about neural networks, but residual. It was just basically a smarter way of doing true deep training. So, or deep learning, right? It was a way for the AI to get better at going deeper. And basically what they did is they broke things up into more layers. That's what they did. They broke it into smaller layers, more layers, but it allowed the AI to learn quicker. That started to speed things up. Like residual neural networks made the learning models go deeper and faster. That started to happen in 2015. Now there's another acronym that also has the letters R and N, but it's not residual, it's recurrent. Recurrent neural networks was all about memory. It was about getting the computer to be better at remembering things for a more extended period of time. And this is very similar. I know it sounds real scary, but this is it. Very similar to human long-term and short-term memory. It's exactly the same. In fact, that's what the acronym LSTM stands for, is long, short-term memory. Yes, artificial intelligence now has short-term and long-term memory. And it all this helped the learning process, right? By the way, as I'm speaking to these things, and it's overwhelming for me because I play these scenarios in my head and I get really excited about it. These are not things that were, one thing was not replacing the other. These are building blocks, right? Like all these elements, most of these elements that we're going to cover today are still used. It's just that they just build upon each other, right?
And the speed of that build, right? Like there's a curve associated with this that got really steep on the upward end over the last
few years,
really 12 months, maybe a little bit more than that, right?
Actually, George, in the last 12 months, what happened, it became mainstream, but we're going to get to the real pivotal moment in a minute here. And that's the one that I really get excited about, because it completely shook the AI industry. But 2015 was all about that memory, improving that memory. Now, it was interesting that Thomas added AlphaGo, because I haven't heard about AlphaGo in so long, but in 2016, basically there was like an algorithm, right? That they took this algorithm and they combined it with some basic machine learning, pass fail type thing. And they use a technique called and it's something I haven't heard in a while, is a tree search. Okay. They combine these three things so that an artificial intelligence can play the game Go. It's a board game. I've never played Go. I don't even know how to play Go. So basically, AlphaGo became an AI model that was really good, exceptionally good at playing board games. Obviously, that they learned a lot of things from this, and they took elements from this for large language AI models later on. But yes, it was all about getting an AI to become exceptionally good at just playing complex board games and winning every single time. Anyway, so that happened in 2016. But George, 2017, this is it. This is the year. This is why I get excited. 2017, in my opinion, was the tipping point for all things AI. 2017. So in 2017, we now have what's called the transformer architect or architecture, right? It's a new approach to architecting AI models and bringing everything together. It was more efficient. It was really a better training model. When I think of transformers, I think about cars that turn into robots, but
yeah. Or that thing on the electric pole.
The thing on the electric pole that explodes every 10 years. It just blows up into green sparks and makes a loud boom. No, it was really about architecting the approach to AI so that it required less time to learn. But transformers is what became prevalent for training, ready for this, large language models. Yep. And of course, all this vast data that led to where we are today. 2017 was that tipping point with transformers, with that new approach to the architecture. And guess what? The word transformer starts with a letter T. Guess what else has T in it? GPT. A lot of people don't realize what GPT stands for, right? They hear Chat GPT because that's mainstream now. Chat GPT, yep. Yeah, but what does GPT stand for? So, by the way, it's also in a word called BERT. BERT also has a T in it. That came in 2018. So GPT stands for Generative Pre-trained Transformer. Bingo. Let's take all this data now. The last, I don't know, however long the internet has existed, plus every book ever written that was digitized. Let's just take all this vast data and shove it into this new transformer architecture and see what we get. Voila. Generative pre-trained transformer, or GPT. That is what, so it was that time, right? 2017 was the pivotal switch to transformer architecture. And then grab everything else that we talked about before about being able to generate stuff and using this architecture, and you have yourself a model called GPT, which can generate content on the fly. And then here comes Google with BERT, just like Sesame Street BERT, right?
Yep.
So BERT stands for bidirectional encoded or encoder representations of transformers. I don't know. I don't come up with this stuff, man. I'm just trying to tell you what they all mean. But basically, GPT and BERT became the two key players for advancing what we today call generative AI, right? But they have different functions, right? So BERT, it's interesting because BERT, the B stands for bidirectional. The AI model is actually able to process text from either left to right or right to left. That's the bidirectional piece. It's able to look at it in both ways, which I found interesting. And also BERT is really, the use case is mostly for like Google Docs, to do that smart composer inside of Gmail, yep. Stuff like voice assistant, all that stuff in the Google suite that's powered by BERT. But GPT, listen, OpenAI, keyword open. GPT, one, it's not bidirectional. It reads text in one direction only, right? So left to right. But it became the go-to for building applications, right? For generating code, for writing articles, for writing podcasts. And so this is, when we speak about Microsoft Copilot, for example, it is leveraging GPT. That's where it's going to. And so that's what GPT stands for. That happened in 2018. Also in 2018, we have this concept. This is, again, mind-blowing to me. So we have this concept known as graph neural networks, or just graph. In fact, you've probably heard of Microsoft Graph. So what happens in 2018 is computers start to process this data in a way that resembles how things are connected, hence the term graph. It's almost like if you create a graph of something. Think of a pixels in an image or words in a sentence, right? How things are connected. So AI starts to look at things from that perspective. In fact, when we speak about Microsoft Graph, right? What are we saying? Well, AI looks at it this way: text messages, emails, SharePoint repositories, OneDrives, all these things, and starts to connect them together into a visual graph. This is why when you ask Copilot to go find, to generate something based on your company's data, it's able to do that because it's able to step back and look at your entire corporate data in a graph and connect things together. Very much like the human brain does.
Yep.
So,
but more quickly, right?
Yeah.
With
Yes.
not forgetting. So
Yeah.
we often, where's that PowerPoint? Oh, maybe we named it this. How do I find it?
Yeah.
Right.
Yeah.
Much more quickly and in a much more accurate way. Not
Yeah.
necessarily in 2018, right?
Yeah.
Advanced substantially since
Oh,
then.
sure.
But absolutely
Oh, sure.
where we're at today.
Yeah. Oh, sure. For sure. For sure. And 2019 and 2020, between those 2 years, roughly, this concept of what's called self and supervised learning also came about. It's really about computers, again, learning more and more and more like humans do and processing like humans do. So we're mimicking the natural way that humans learn, but using a computer. That's what it is. Because how do we learn? Well, there's stuff that we do on our own, and there's stuff that we're taught. And so that self and supervised learning approach, it basically the AI is mimicking even further how we as humans learn. And guess what? It's doing it much, much, much faster. I read an article recently, which I found interesting. Not recently, it's been a while, but I started to really get into music and how AI is kind of impacting the music industry. And
Yep.
apparently the self and supervised learning approach to deep computer learning really became very prevalent and had promising results, believe it or not, in audio signal processing. So apparently it's a big deal in the music world or the audio worlds in general. So I found that interesting. And I can see that because, and think of a sound engineer or a producer where there's things that maybe they figured out on their own, but they didn't learn everything to that job on their own. There was somebody who has 20 years of experience, who has a lot of nuances that
Yep.
you can't learn from a textbook, came and coached you on something. You're like, whoa, that is awesome. Now he's transferred that knowledge to you. That's what this is doing, right?
Well, and you might have seen yesterday, they released the last Beatles song. It was a song that John Lennon had recorded, I think it was 1977, on a cassette player. So the quality of the song wasn't good, and they had tried for years to piece it together. Now, with the advent of AI, they were able to piece it together. Yeah, I saw it late yesterday.
Nice.
And they were able to piece it all together into a song without noise, right? It had a lot of background noise on the cassette tape. They've integrated all the original Beatles into it, and have been able to process it and release it as a single. So
really,
something that you could have had engineers do maybe, but not at the level that it's been done at, but they weren't able to do it or chose not to do it because they couldn't get to the right quality level. And now with AI, they've gotten it to the point that it's actually a solid sort of put together song and releasable.
That is fascinating. See, so yeah, I'm going to look that article up. That's plus, we're We're Beatles fans. Who isn't a Beatles fan? That's good to know. I'm going to look it up. Just now we're coming to the end, right? Here we are. We're at 2021, heading into the home stretch of 2023. Again, it's interesting that Thomas has AlphaFold. AlphaFold is not something that you and I would ever run into. We're as frontline information workers, this is not something we would use, but in the medical field, it became a big deal. But basically, without getting into too much detail, AlphaFold was an AI system that was able to predict, ready for this, the 3D structure of a protein, okay, based on data like, what type of amino acids and all sorts of elements and chemical data that would get fed into the AI. The AI would then produce a three-dimensional picture of protein. And so a lot of times nowadays, when you see some type of representation of cells or proteins or viruses or DNA, these images are now generated three-dimensional accurately through AI because of stuff like this. But yeah, it's big in the medical and biological research realm for sure, and that happened in 2021. But here it comes. Now, this is the stuff we all love. In 2021, GitHub Copilot was launched. GitHub is a developer's platform for Microsoft, and developers start using Copilot in 2021 to write their code. Yep. So it kind of turned the entire programming world on its head, because now you could be like the best developer, great, but with Copilot, you became even better. And I read an article recently that they kind of interviewed a bunch of users within GitHub, and there was no negative comment whatsoever on Copilot. They absolutely loved it. They found themselves to be more productive. A lot of these developers are independent contractors, so they were able to finish jobs quicker and move on to new jobs and making more money. See, that's what's nice about this. Is like you were thinking, oh well, Copilot's going to replace developers. No, they just became better at what they do, and they did it faster and were able to do more. So I found that very, very interesting.
And
so
we've talked about that a lot, right? There's two layers. One I'll bring up that we haven't really talked about before, but it's people are like, is AI going to take my job? And the answer today is the person using AI might take your job, right? AI itself is probably not going to take your job.
That's a good point.
The same holds true for corporations. There's a window of opportunity now where companies who take advantage of AI, take advantage of Copilot, take advantage of some of the other tools, in particular in the Microsoft platform, will be more successful than those who don't. And in fact, at the margins on that, there's likely a binary outcome. So there will be organizations who, by strategic choice, don't use it, right, or lack of capability or lack of funding to implement it, will not use AI or will not leverage it in a significant way.
Right.
They're going to be the losers, right?
Yeah.
And somebody else will gain market share. They'll become more efficient. They'll become more productive.
If you want to compete, you got to embrace AI. That's the bottom line.
Yeah.
I keep saying that. By the way, the GitHub Copilot, that's where it started, but it is the same Copilot we speak about. This is the Microsoft Copilot. In other words, now we know that Copilot is in Bing. They rolled it out to Windows 11. As of a couple days ago, November 1st, they went ahead and rolled it out to the enterprise customers in their Microsoft 365 suite. It's going to roll out in the Microsoft phone system in the first quarter. It's just going to keep going. Like, there is no stopping this train. And so Copilot is going to be how we do work moving forward. So yes, we have to embrace it. We have to learn it. And of course, that same time period of 2021 across 2023, DALL-E came out. This is, again, OpenAI, same people who own GPT, They have DALL-E. It generates images based on text descriptions, right? This is what we did in the previous podcast where we pinned DALL-E up against Midjourney. And actually, I realized after the fact, when I went back and kind of watched things, it's nice because the preview that Microsoft gives you inside of Copilot for Microsoft Edge for the browser,
Yeah.
the DALL-E generation that you get out of that platform is actually DALL-E 3. It's the latest version of DALL-E, so that's pretty cool that you get that in the preview mode.
So I haven't watched the podcast yet. Was there a winner?
So it was so hard. Here's where we ended. We struggled with it. There was not a winner because they were both exceptionally amazing, but they were different in their own way, and that's what made it. So that's why it was too difficult to kind of choose a winner. We did pull up and we displayed the results, one result from each side by side, so that the audience can go ahead and chime in the comment section when they see it. But my takeaway was it's hard for me to say win because they were both so good, but they were so different, and that's I think that's where I think that's what's going to happen from now on is, people in marketing or people in the design role, they're going to go, I'm not going to stick to one platform. I'm going to have 2 or 3 and give it the same prompt because there's variations or differences between them, and now I have more options to choose from. But they were just so good. The images were so exceptionally good that it was hard to choose a winner, honestly.
And the speed again of change, right? There's a lot of trigger points in here where major things happened that helped it advance. But again, it feels, if you think about that, the Gartner hype curve, right?
Yes.
I was at Gartner Symposium a couple of weeks ago, and they talked about us getting close to the peak of that hype curve, right? That hype curve from a progress standpoint. Usually when you fall off it goes into disillusionment and people haven't really been able to implement it or get the business value out of a certain technology, right? And then it ramps back up again. I don't know that we're going to hit that trough with this because the usefulness and the speed of change, having multiple tools like we just talked about does give you choice.
Yeah.
So at some point, organizations might choose one over the other or come up with a model to aggregate and enter prompts and get results from 2 or 3 at the same time, right?
Yeah.
And be able to be the human in the interaction and select from the outcomes and choose the path forward, which on one day might be with one tool and another day might be with another tool. But that does allow the world and these developments to move forward without all converging either, right? Because if they all converge, then there's no differentiation, and we sort of get this groupthink going that's not valuable, right? Because you narrow the set of potential outcomes. You want to broaden the set of potential outcomes from all of these standpoints, whether you're using it for written content or graphical content or data analysis or code development or whatever it is.
Yeah. And you know what? For example, OpenAI now has an enterprise level agreement for ChatGPT. I can see all these other platforms doing that, where they're just going to say, hey, look, we're going to give you more features, more capacity, more speed, more prioritization, more results if you sign up for this. And so I can see that happening across the board with all the different types of AI platforms that are going to eventually spin up. And to your point, depending on the company's philosophy, but I think you sign up for multiple ones because you're going to get different results, and sometimes you may want to combine stuff from one and the other and make something that's very, very much unique in yours. But so DALL-E, I'm enjoying it, and I know that Sam really likes Midjourney, but he's actually entertaining using the paid subscription version of DALL-E now after seeing the results. So, all right, and here we are, home stretch 2022. So this thing called stable diffusion, this the Stable Diffusion is really more about, again, using deep learning, right, to generate images and whatnot based on text description. So it got really good at the prompt. This is what made prompts so successful using natural language. It just got better at it, and so it stabilized that whole process. And here we are, 2023. We got ChatGPT on its fourth version. We have DALL-E on its third. We have Microsoft Copilot rolling out like crazy, shaking up the entire Microsoft world. I mean, this is where we're at. And all this really has led to where we are today, which is that green box at the end there, which is, AI that's able to generate very unique content and unique results based on the input we give it. So, man, this is a great graph. He really thought through this, and I love seeing some of these names that I haven't heard, things like AlphaGo and even the VAEs. I haven't heard that in so long. So it's nice to take a step back but honestly, George, I walk through this, and while I walk at a high level, in my mind, my head's spinning because it reminds me of how far we've come. And can I tell you something? This is just the tip of the iceberg. If we think that these last 10 years is what defines AI, no, it's what defines AI as far as where we're at today. This is going to happen so fast that within 12 months, we'll be talking about stuff that we've only dreamed of. And that, by the way, that's the thing. The speed in which AI is developing is because we have all these building blocks in place. And trust me, there'll be more building blocks that are going to be added to this matrix. But my only hope is that they don't start regulating it to the point where they slow down the speed of progress. That's the thing that just I really hope that doesn't come to that. But
and that's an interesting point. The part of the discussions at Gartner a couple of weeks ago were around two things. I saw two sort of distinct approaches to leveraging AI platforms. One was they either had their own platform that they were trying to promote, or they were using a single platform, right? So that was one of the threads. The second thread was what we talked about a little bit ago, which was aggregating multiple LLMs, using them in unison, generally with a private data lake, right? That was storing your data and interacting, right? So this leads to regulation. And we've talked on previous podcasts really around what's regulation going to look like, what should be included in it, should industries or other constituencies get together to form their own regulation. Those were the kind of things we were talking about. But what I heard consistently in some very specific threads at Gartner were, how do you survive an audit, right?
Yeah, that's a good point.
So the regulation is going to happen. To your point, the hope is it's not so onerous that it stifles development or use or anything like that. But people do need to start to think about, what are they going to do with the data in their environment? How are they going to use it? How are they going to survive an audit effectively? Will they be able to prove what they did, how they did it, what data was used, where was the data stored, all of those things that happen behind the scenes that will effectively be regulated, right? But the ability to sort of track and trace what actually happened to get you there seems like it's emerging as the more important thing than the regulation itself, right? And again,
the transparency piece, the accountability piece, explaining how you generated what you generated, where did it originate from? All right. Well, listen, so I could talk about AI for another hour, George, but I can't. so our producers will not allow us to do so. And so we have to bring this podcast to an end. Folks, thank you for joining us on this journey, this 10-year journey of AI. This is kind of like the one episode that's kind of be the launch pad for a lot of AI discussions coming in the future, right? And so we just wanted to kind of share with you all how we got to where we got. And so thank you for joining us. This does bring our podcast to an end. This is a good time to remind you all to subscribe to Tech Unmuted on your favorite podcast platform. In fact, do it right now. Right now. I'm not leaving until you do. Folks, thank you very much. Till next time, stay curious, stay connected. See you all next time.
Visit fusionconnect.com/techunmuted for show notes and more episodes. Thanks for listening.